Good day. Today I will be discussing science for grade 4, how to classify minerals and how many ways we can see how to classify minerals. Now, this lesson will be found in our interactive science books for grade 4s on page number 239 to page 243. Mineral crystals. So minerals are small amounts of chemicals, or what we like to call elements in science, that are found all around us. So even if we breathe in air, we breathe in oxygen, and that's called a mineral as well, or an element. So oxygen is found here on the periodic table, and helium. So if we take helium and oxygen and we combine these two elements, we get something called water. So H2O, so we take two hydrogens and one oxygen element, and then we bind them together and we get oxygen. And so do all of these elements that interact with one another form different kinds of elements around us that are found in the Earth's crust. Mineral crystals like table salt are non-living, okay? So any kind of crystal that you find, it is a non-living element. And each mineral has the same chemical composition as the one that is found somewhere else on Earth. For example, quartz that's found in Asia has the same chemical composition as quartz found in the Americas. Now, there's 6 different ways to identify minerals, and these 6 ways are called cluster, luster, color, hardness, streak, shape, and cleavage. Now, the first one that we are going to look at is the color. Now, if we look at the color on the left-hand side, we can see that it is a green color, and it looks similar to the structure of the crystals on the right-hand side. The difference is that it is red. So this is quartz found somewhere on Earth. Now, why this is different color from this is because they have interacted with different kinds of minerals. So color is not enough by itself to identify a mineral. So luster is another way that we can look at minerals. So you get 2 types of minerals, metallic minerals and non-metallic minerals, which shines light off of them or absorbs light. Now, the metallic one is you get a very shiny one that reflects the light very, very good, which gives it a very mirror-like image. But if you look at this one, the metallic one on this side, you can see it's a very dull color. So it's still metallic, but very dull. And that is why, because it absorbs light much easier. Non-metallic minerals are classified in 6 different ways. You get the vitreous, silky, resinous, waxy, pearly, and earthy-like minerals. So vitreous is glassy, brilliant. Like quartz, it is very glass-like. So we all know what a glass feels like. It can shatter very easily. Now, resinous is like a plastic feel, so it feels more like something that is plastic, like the remote control of your PlayStation. Waxy is a greasy, oily feel to it. It can scratch very easily. The next one that we look at is a pearly. So pearly has a more rock-like feel to it, but it has a smooth texture to it. Then you get earthy. Earthy is rough but dull, so it has this rock structure to it. So that is one other way that we can look at how minerals can be classified. The third way is how hard a mineral is. So how we can identify this is how easily the surface of this mineral can be scratched. So the first one that we look at is the diamond. So the diamond on this side is very hard. The reason for this is because carbon atoms have been pressed together so tightly, and the heat of the Earth's surface or the mantle has changed the chemical composition inside the carbon structure itself, aligning them in such a way that light can pass through them. So they are very transparent. But obviously they don't look like this when we take them out of the earth. We still have to polish them. And then the second one, the softest one that we can look down or at is the talc. Now, talc is very soft that we can, if we take it and we scratch it against another surface, any kind of surface, actually, it leaves a residue behind. So if we take the diamond, for instance, and we scratch, actually nothing comes off of it because it's so hard. So if we look here, there's a table down here that can show us more likely where the minerals are on the scale of hardness. So the first one will be talc, and then gypsum, and then calcite, until we get diamond, which is the hardest one. And each mineral before that can be scratched with the mineral after that. So let's say, for instance, we take fluorite and a diamond. The diamond will easily scratch the fluorite, where the fluorite cannot scratch the diamond. The next thing that we can look at is streak. Now, streak is the color left behind if you scratch the mineral on a piece of paper or on a special piece of paper. So if we look at the minerals on this side, we can see that this is a very hard mineral because it did not leave a streak behind. It doesn't mean that it does not leave a streak behind if you don't see a color. The color can just be so faint that you cannot see it. Then if we look at the next ones, we can see that it leaves a brownish color, a lighter brown color or a metallic color. So when we scratch it on that piece of paper, we can see what type of color or what type of mineral it is. Sometimes minerals leaves a different color than the mineral it looks like. So if we look at pyrite, it has this metallic color, and when we scratch it on that paper, we can see it leaves a dark color that more or less the same as the mineral itself. But cinnabar leaves a brownish color when it has this gray color to it. And that is because the chemical composition inside it, when it gets released, it changes the color. Now, shapes of crystals can often be used to identify each crystal. If it's a solid shape, the flat faces of these crystals can be squares, rectangles, triangles, diamond shapes, or hexagons. So the shape of the mineral under a telescope or microscope, not a telescope, under a microscope looks similar to these structures here. So we get cube structures and rhombohedrons, six-sided prisms, and six-sided plateae. Now, pyrite looks like this, or a diamond will look like this because of the structure inside the mineral itself. The cleavage, the last one that we are looking at, is how a mineral breaks along smooth path lines or planes to the zones of weakness it bonds to. So here are 4 different ways crystals can interact with one another. Okay, the first one will be crystals just growing on top of one another. For example, muscovite. Or the second one will be feldspar. Feldspar looks like this. Now this is feldspar here. And then the third one will be halite, okay, because it interacts on different types of planes, more than 2 planes. And the third one will be calcite, which is a little bit stronger than any one of them on the top there. So if we look at this lines or these lines here, we can see that if I would have applied enough pressure, it would break along those lines very easily. So that is the 6 different ways that we can identify minerals from one another. And I hope that you guys understand it a little bit better. So thank you for watching the video, and I hope to see you in the next one.